Before proceeding with the installation, configuration, operation, or maintenance of these products, please ensure you have thoroughly reviewed all relevant documentation provided by Balluff and other pertinent sources, including installation guides, configuration manuals, and operational protocols. It is essential for users to adhere strictly to all applicable codes, laws, and safety standards during installation, wiring, adjustment, and operation. Installation, configuration, use, assembly, disassembly, and maintenance of these products must be performed by individuals who have received appropriate training and are fully versed in following the outlined procedures and safety measures. Failure to comply with these prerequisites may result in noncompliance with legal and safety standards. We expressly disclaim any liability or responsibility for damages, whether direct, indirect, special, or consequential, arising from the use or application of the information contained herein. Balluff, Inc., in no event, will be held accountable for any damages incurred as a result of using this guide. The content of this guide is intended for illustrative purposes only and does not ensure suitability for specific applications due to the diverse range of variables and requirements in different scenarios. Users are entirely responsible for verifying the applicability and safety of this information for their unique situations. Acceptance and use of this information come with an understanding that any and all risks associated with the installation, configuration, assembly, or use of these products are fully assumed by the user. Please note that this document does not serve as a warranty of any sort, nor does it modify or supplement any valid warranty provided by Balluff, Inc. for these products. The information herein supplements the original warranty terms without altering them.
In this tutorial, we will go through the initial Modbus TCP setup on a Balluff Black and Silverline multi-protocol I/O Link master module. The Balluff I/O Link master module behaves as a Modbus TCP server on the network. Our network layout consists of having a PC running Modbus TCP client software connected to the Balluff multi-protocol I/O Link master module. The Balluff module supports multiple Modbus TCP client connections, such as multiple PCs or PLCs that became connected to the module. Connected to the I/O Link master module in this example is a Balluff I/O Link condition monitoring sensor at port 1, and then on port 2 is a BNI 007Z discrete I/O Link hub. The discrete I/O Link hub can be set up for inputs and outputs on each of the port through its parameters. The first step is set the protocol of the Balluff multi-protocol master into Modbus TCP server mode. This is done by going into the web server of the Balluff I/O Link master module. Open a web browser such as Chrome and type in the IP address of the Balluff I/O Link master. The default IP address of the master is 192.168.1.1. The Balluff engineering tool can also be used to set the IP address of the I/O Link master. Once the IP address is entered into a web browser, log in to the module if necessary. Then click on the settings icon on the right hand side. Once in the settings, select Network. Here under Network, the Fieldbus protocol can be set. If Modbus TCP is not selected, select Modbus TCP and hit the Set button. This will reboot the module and put the Fieldbus protocol into Modbus TCP mode. The network settings can also be used to set up the IP address of the I/O Link master device. Once the network settings are set up for the module, the next step is to enable the I/O Link ports on pin 4 for the I/O Link master module. This can be done in two ways. The first way is to click under the Ports tab. Then, under Set Configuration, all the ports can be set up independently. So, for example, port 2, pin 4, I/O Link can be set by selecting I/O Link Auto Start. And then pin 2 can be set up as a discrete input or output, depending on the particular I/O Link multi-master that you're using. Otherwise, all ports can be set up on top for set configuration for all ports. From here, you can use the pull-down menu and set I/O Link Auto Start and Digital Out. After this is selected, select the Set All button. This will then set all the I/O Link ports on the multi-master. Once set up, pin 4 on the master will physically be either solid green when an I/O Link device is connected, or flashing green when the pin 4 is set up for I/O Link mode but no I/O Link device is connected to it. Otherwise, I/O link ports can be enabled through the Modbus register map of the I/O link master module. The port configuration on port 1 starts at index or Modbus register 9100. Port 2 starts at 9200. Port 3 starts at 9300, and so on up through port 8, which starts at 9800. Within each of those register maps, the first register at 9100 is setting up the master cycle time for the I/O link. This is normally coded through the I/O link device. At 9101 register, this sets up pins 2 and pin 4 on the particular port of the I/O link master module. 9102 sets up validation ID as well as setting up whether you want an I/O link parameter backup of the I/O link device. The next three registers, 9103 through 9105, sets up the vendor ID and the device ID of the I/O link device. This verifies that the correct I/O link device is plugged into the particular port before backup and parameter restore is done. Next, we'll bring up the PowerHub Modbus tester software that's used to communicate to the Modbus TCP server on the I/O link master module. We'll be connecting to the IP address that's set up on the I/O link master module, which is 192.168.1.1. The port is set up for the default Modbus port of 502. A timeout and a delay between polls can also be set up. The slave ID on the Modbus setting will be a value of 1. The Modbus I/O link master module supports the function 03 for read holding registers. This is used to read all registers. For the writes, the Modbus I/O link master module supports Modbus function 16, which is a write multiple register command. From here, you can select connect, and then the connection to the Modbus master would be established. For the I/O link port configuration, we will be looking at the starting register of 9101. For the register value of 770 decimal, we can go to display and select hexadecimal. This will make it easier to look at the data that we're looking at. The data then comes back as a 0x302 in hexadecimal. The 9101 register, the 03 is the high byte, or byte 1, that's telling you pin 4 port mode. A value of 03 shows that it's currently set up as a digital input. The low byte, 02, then shows you byte 0 of 9101. This shows pin 2's port mode. By default, that's set up as a digital output. So currently, it's set up as a digital input and a digital output on pins 4 and pins 2. In order to enable it, the I/O link auto start, we would have to change it so that the high byte, or byte 1 at 9101, needs a value of 02 to set it to I/O link auto start mode. Pin 2 port mode we could set also as a 02 for a digital output. In order to do this, we would go and use the Modbus function write multiple register command. By selecting command 16 through our testing software, we can enter the values that we want to set up for 9101. The value type would be shown as hex, and we want to put in a value of 0202. If we were to set up validation and the vendor and device ID, we can then put it in 9102 through 9105. In this case, we only want to turn on I/O link for port 1. If when we hit the send button, we get a command prompt that the write multiple command was successful. Now port 1 should be enabled for I/O link mode. In order to set up port 2 to also be in I/O link port mode, we can also change that address to 9201. Here again, when we go look at the data that's currently at port 2, we can look at display and change that to hex. And we could also see that it's also set up as a digital input on pin 4 and a digital output on pin 2. So to set this for port 2, again, we can use the Modbus function of write multiple registers, value type hexadecimal, and write in a value of 202 hexadecimal. This will then set up O2, which is IO-Link auto start for pin 4, and then pin 2 port mode as a digital output. Once we hit send, we get a confirmation that it's successful. Once successful, the LED on pin 4 would be flashing green or solid green, depending on if an IO-Link device is connected to the port or not. We can do the exact same thing over and over again to set up ports 3 all the way up to ports 8 by changing the start register. 9801 would be for port 8 on the IO-Link master module.